This week we're looking at the history of the atom. So I want to start with a question. How long have people been interested in understanding matter and its structure? Think about these 3 or 4 answers. Thousands of years, hundreds of years, only a few years, or never? Well, the correct answer is thousands of years. People have been trying to understand what substances are made of and how those things interact. So just as a review, this lesson allows you to see how the theory of atomic structure has changed over time, which is one of the characteristics of a scientific theory. That as new information becomes available, theories will change, or parts of theories will change. If you take a look at the term theory in your glossary, you'll see that this is one of their characteristics. So what do you think led to the changes in the theory of atomic structure? It's possible that many things could have led to changes in this theory. So we're going to take a look at a few of those. We start out with the ancients. These folks are mostly Aristotle and Democritus, and they studied this more than 2,000 years ago in ancient Greece. If you think back to your time in 7th grade history, this is when you were studying the ancient Greeks. And Aristotle believed that there were 4 elements: earth, air, fire, and water, while Democritus, a colleague of Aristotle's, believed that matter was made of small particles that he named atoms. They used observation and inference to explain the existence of everything around them. So basically, they only had what they could see with their naked eye, or experience with their 5 senses. They didn't have any tools that allowed them to see or experience things beyond. So here we have Aristotle and Democritus, the ancient people who first started discussing, and a lot of their study was discussion and thought experiments. They first started discussing, well, okay, what is water made of? What is air made of? How are they different? The next group of people we had were the Alchemists. This was like the Baroque time period. This was like the 1600s, 1700s time period. These were generally European scientists, roughly 800 to 900 years ago in Europe, obviously. And their work developed into what is now modern chemistry. They were mostly concerned, the official alchemists, and there were lots of other groups of individuals who were just kind of scientists at the time. They were officially concerned with trying to change ordinary materials into gold. They thought by doing certain methods they could take something like lead or mercury and turn it into gold. So that's kind of what they were trying to figure out. But in doing that, they learned a lot about matter and its structure. These are some of the alchemical symbols they may have used at the time to represent different things they were talking about, like antimony and arsenic and bismuth and copper and a variety of other things that are still on our periodic table today. Then we move into what is considered the more modern theories of the atomic structure. We start with John Dalton. Dalton did his research in 1808 in England, and he described atoms as tiny particles that could not be divided. He verified the existence of atoms through experimentation with gases and compounds. And he thought each element was made of its own kind of atom. So these are pivotal ideas that no one before him had really been able to prove, but his experiments were able to do that. He started building on the ideas way back of the ancient Greeks, who lived even 1800 years before he did, of Democritus. And so here we have John Dalton. His model was called the billiard ball model because while he realized that substances, air, water, rock, they must be made of small particles of matter, He envisioned those small particles as solid and hard spheres like billiard balls. So he kind of used these wooden spheres to model them. And you can still see now in science labs, chemistry labs, you can still see these billiard ball models that have the springs that attach the balls together, and then you can use that to build compounds and elements. Then we move to J.J. Thomson, and his major contribution to the theory of atomic structure was the discovery of electrons. This happened in 1897, so not quite 100 years later than John Dalton. In England, he discovered that electrons were smaller particles of an atom and were negatively charged. He knew that whole atoms were neutrally charged, but he couldn't find the positive particle. So he knew that the atom as a whole had a neutral charge, and he knew that there was a component of that atom that had a negative charge, but for whatever reason he could not figure out where the positive charge was that would cancel out the negative charge. And here we have J.J. Thomson in his lab. His model was nicknamed the Plum pudding model, and if we were thinking about the plum pudding model, we might think of a watermelon, where the electrons are all the seeds inside a watermelon. So let's take a look at Thomson's model. And we'll do that later. Then we get to the next individual, Ernest Rutherford. So now we're up to what we actually call the theory of atomic structure. This was in 1911, so not very far later than J.J. Thomson, so only about 20 years, 15 years later than Thomson. Also in England. He conducted an experiment to isolate the positive particles in an atom, and he decided that the atoms were mostly empty space, but they had a dense central core. And you can guarantee that Rutherford and Thomson were not working completely unaware of what the other person was doing. So while Thomson was thinking about the negative particles, Rutherford, and they would be communicating back and forth through letters about, Rutherford was thinking about, okay, so where is that positive particle? He knew that atoms had positive and negative particles, but he could not decide how they were arranged. So he could show that there were positive particles, but he couldn't decide about their arrangement. And here we have Ernest Rutherford. So his experiment was called the gold foil experiment. And this showed that there was a core, kind of like the pit in a cherry, that was different or had a different mass in the middle of the atom. And if you want more information about how he did that, look up the gold foil experiment, and it will explain how that happened. And then we have atomic structure 2. So now we're getting even more modern. We have Niels Bohr. This was 1913, so basically the exact same time as Rutherford and Thomson. Also in England, he proposed that electrons traveled in fixed paths around the nucleus. So he kind of built on Rutherford and Thomson's ideas of, okay, there are positive particles, there are negative particles, now how are they structured? And he decided that they kind of work like planets. Scientists today still use the Bohr model to show the number of electrons in each orbit around the nucleus. And he was trying to show why the negative electrons didn't get sucked into the nucleus of the atom. So he assumed that they had to be traveling on some fixed path, kind of like the planets travel around the sun. Or if you think about it, he was looking at electron orbitals, kind of like the layers in an onion, or in a tree ring, or in a giant jawbreaker. And now we have what scientists consider the most accurate model today, called the electron cloud model. In this model, we realize that electrons travel around the nucleus in orbitals, but we cannot predict where any atom will be at where any electron will be at any given time. So it would be like saying the gym teacher and her students are in the gym, but we don't know where in particular any given student would be in the gym. Maybe they're by the basketball net, maybe they're over by the bleachers, maybe they're by the door. And if we think about it in terms of an atom, what this means is that electrons are traveling so fast around the nucleus of the atom that they appear to form this cloud. And they're somewhere in this cloud, but they're going so fast that we can't pinpoint exactly where they are. This is also known as the quantum mechanical model, which is a theory for describing the position and arrangement of electrons in an atom. So the electron cloud model, we end up with a picture of an atom that kind of looks like this. And neither of these are to scale in any sense of the word, but if we have this tiny nucleus in the center, then we have even smaller electrons somewhere in this cloud circling around the nucleus. But not to be confused, we also still have orbitals, so there are kind of regions where the electrons would be found. If there are any questions with this slideshow, please make sure you send me an email. Thanks.